Write an equation for the function graph, then determine the intervals on which the function is increasing, decreasing, concave up, down, and then find all the logo extrema. So for this problem, before we get to started, right, let me remind us some formulas, right? Let me remind us the multiplicity of the x-intercepts and also of the vertical asymptote. Okay, so then for the x-intercept, let me write down. For x-intercept, we have three types of multiplicity, right? So imagine if this is an x-axis, three type of them would be, first of all, if we have a crossing one, right? If the graph is crossing the x-axis, this one is crossing, then at that x-intercept, it should have multiplicity of 1. Okay. Another type of it is that if the graph is bouncing back on the x-axis, right? It can go up and down like that, or it can go like this. Like either way, as long as it's bouncing through the x-axis, well, bouncing's against the x-axis, as long as it's not crossing through. This one is what we call by bouncing back. This is what when we have multiplicity of 2 at that x-intercept. Okay, and the third case is when we have it crossing but with a curve. So it's gonna go down and it's flat and then it goes continue to go down. So at here we're gonna say the x-intercept, it has a multiplicity of 3. And usually I'm gonna put the word curving, right? Because it's like it crossing by with a curve, not a straight line. Okay, and then that's how you know that that x-intercept should have the multiplicity of 3. So let me just get like one notation for this, right? So this one M2, M3, and this one would be M1, right? So let me write down M1, M2, and M3 for the multiplicity, okay? And then for vertical asymptotes, right, before we get into the math work, for the vertical asymptotes, we have two types of multiplicity. Imagine if these are your vertical asymptotes, right? You're going to look at the behaviors on the left and on the right hand side of your vertical asymptotes. If the graph, they point on different direction, right? Say this one is like, one is like on the top left corner and the other one is on the bottom right corner like this. Then your asymptote, it has multiplicity of 1, right? Different direction is odd for multiplicity of 1. 1 is an odd number, right? If the graph is pointing at the same direction, either go up or go down on both sides of the vertical asymptotes, right? It can either both go up or both go down, then you would know that this asymptote, this vertical asymptote, has multiplicity of 2. Okay? So now that we get all that reminded, right, let's get into the real work in here. So first thing first in here, what I want to see is that first thing first, you're going to help me list out all the intercepts. We have two types of intercepts. We have x-intercept and we have y-intercepts, right? So by the look of this graph in here, we only have one, or actually we have two x-intercepts. We have x equal to 1 and we have x equal to 6, okay? So x-intercept, you can list them as a point, or you can do x equal to 1, comma, x equal to 6. I'm cool with either one, okay? For the sake of this problem, I'm just going to list them out with the x, like this. And then the second type of intercept, we also have y-intercept. So for this problem, the y-intercept, it would be y equals to a fourth, or 0.025, a fourth, which is 0.25. This one is a perfect number. That's why I put it as, the decimal. If it's not a perfect decimal, if it's a non-repeating decimal, I would refer a fraction, okay? So if you want to, you can put them as a point, right? And we all know the y is the second value of the point. So that's why for the y-intercept, you have to go 0 and a fourth. Or the other way around, you can also do 0, comma, 0.25. Okay, comma, 0.25 like this. Either way. And then let's talk about the asymptotes. So first thing first, let's talk about the vertical asymptotes. we have two vertical asymptotes in here. We have x equal to -3 as going from left to right. And the second one, it would be x equal to 4. And for the asymptotes, make sure you don't just list out the values of x. You also have to attach a variable in front of the equal sign, okay? They are lines, they are functions. They are not just a value. And follow up by that, for the other type of asymptote, we also have horizontal asymptote for this type problem, right? We have a horizontal dashed line at y equals to -2 because it's hitting the y-axis. And same thing in here, it's not about a value. Asymptotes, it has a variable equals to a value. So make sure you put both of them out, okay? So let's talk about the multiplicity of everything in here, right? Let's do it in, I guess, orange for the x-intercepts in here. At 1 is bouncing, as you can tell. So this one has a multiplicity of 2, right? And 2 for multiplicity of 2 at 1. At 6 is crossing by. It's not flat, it's just like crossing by, right? So this one, it has multiplicity 1 and 1, okay? And let's talk about the vertical asymptotes in here. Let's do it in cyan, right? At -3 in here, we have bottom left and we have top right, different directions. So that would be odd, multiplicity 1, right? And then for x equal to 4, we have both going up on both left hand side and the right side. So that means even, right? So that would be multiplicity of 2, okay? Now that we have all of that, right? So let's put it into an equation. So we're gonna go y equals, right? We need a y because we're talking about equation. An equation would have two sides of the equal signs, right? It should always have the y on the left hand side. And then to connect everything together, the x-intercept, we're gonna put it on the top of the fraction. So we're gonna switch around. So x equals to 1, it would be x minus 1. Let me put it in red. For the first one, x minus 1 with multiplicity of 2, so it would be square. For the second one, it would go x minus 6. We switch it around. Multiplicity of 1, you can put a 1 in here, or you can choose to not put a 1 in there, right? Either way. And then continue with the fraction. Now let's talk about the vertical asymptotes. Switch it around, you're gonna get x plus 3 with multiplicity 1. Again, you can choose to put a 1 in here for the power, or if you don't want to, that's fine. And then the other vertical asymptote, we switch it around to have x minus 4, right? And then multiplicity of 2, so we're gonna put a square in here, okay? And then you might ask me, well, what we're gonna do with the horizontal asymptote and the y-intercept, right? Because we haven't talked about it yet. So usually, just like how you did, other problems, we should have a coefficient, right? Like what if we do have a coefficient and what we're gonna do about it, right? So this time in here, let's just put an A to represent the coefficient, right? Let me do it in light green. So light green, let me just put an A in here to represent a coefficient. And after this, I need to find a value of A. So what I'm gonna do to find a value of A in here is that I'm gonna plug in a point that I haven't used from before. And I'm thinking about the y-intercept. This one is the point that I haven't used, right? So let me just circle it because I'm using the box for the final answer. So let me just circle it first, okay? And then we all know that the first value would be x and the second value would be the y, right? So let's plug it in. We're gonna get 0.05, or if you want to, you can do a fourth, either way, equals A, and then the x in here would be 0, so you plug in 0 in for wherever you have x. All right, and then in here we have 0 plus 3, 0 minus 4, square, and fraction bar. And then do it out. On the left hand side, we're still gonna get a fourth. On the right hand side, on top in here, you're gonna get 1 times -6, which is -6a. On the bottom in here, you're gonna get 3 times 4 squared would be 16. So 3 times 16, you're gonna get 48. Okay, and at this step in here, how do we go about it? Well, we're gonna cross multiply it. Okay, so let me switch it back to black. So 48 times 1, I'm gonna have 48 in here. And for the other side, 4 times negative 6, I'm gonna get a negative 24a. If I dividing everything by negative 24, I would have my a equals negative 2. Okay? And then how do I get the final answer? Well, let's plug it back into the equation that I have in here, right? So I'm going to go y equals, my a is negative 2. Let's just put it up here. And then tracing the red one, which is negative x minus 1 square, and then x minus 6. And on the bottom, I would have x plus 3, and then x minus 4 squared. Right? And am I done yet? Well, let's see. We have 4 pieces of information. We use the red for the top. We use the blue for the bottom. We use the y to get the coefficient, which is a. The purple one, right, the horizontal asymptote, we haven't used it. Guess what? It's meant for checking, right? So it's here, right? So we know that we have the right answer because this one, again, it is used for check your answer. It's only used to check your answer, okay? So in here, we have a matching number. In here, we know that we add the correct place. So this is actually your final answer, and it's correct. Okay, let me just box it.